good morning, students. This week's lesson is getting under your skin. Let's go ahead and begin. Introduction, pursuing another lead. The team here at the Infinity Space Center are pursuing another lead that might help you on your mission to Mars. We believe that there is another aspect of being in space that may explain your bone loss you read about through your ROS report. Let's walk you through some of what you've learned so far. Hopefully you can make sense of it and use the information to help your crew. Do astronauts get direct contact with sunlight? Click on the images below to gather evidence about the following question. Do you think astronauts will get direct contact with sunlight while in space? All right, pretty interesting. So we have a picture of a woman standing in the sun. Here we have an astronaut seems to be looking out the window. There's light coming from somewhere. Do you think that the actual bodies of these astronauts get real sun? My guess is no. Oh, we can click on these. Okay, on Earth we can usually soak up some sun right when we step outside. The windows on a spacecraft are designed to prevent pure sunlight from passing through. I wonder why. Yeah, I wonder why. What do you think is dangerous about full-on sunlight from that close to the sun? And what is missing between the Earth and the spaceship that might block some of those rays? Think back to our last unit. Here we have some serious bling. The reflective covering on this astronaut's helmet prevents harmful rays from damaging their eyesight. And finally, when outside the spacecraft, astronauts can get in contact with sunlight. It's a good thing they have those suits on. Okay. Another key difference, here we go. Another key difference between living on Earth and in space is direct contact with sunlight. You may be wondering what sunlight has to do with your mission, the risk of fracturing bones, or preventing bone loss while in space. The rapid bone loss experienced by astronauts in space typically does not occur in humans on Earth who have direct contact with sunlight. So maybe direct contact with sunlight can help explain the bone loss in astronauts. Here in the lab, we're looking at this connection. Do you think there's a connection between the lack of direct contact with sunlight in space and bone loss? So go ahead and write what you think there. Sunlight, helpful or harmful? To find out if the lack of sunlight can lead to bone loss, you'll need to first understand how direct contact with sunlight affects the human body. Sort the various effects of sunlight into the two categories below. So here we have benefits and harmful effects. The sun in your skin can help cells activate the production of important vitamins. Seems like a good benefit. Astronauts wear space helmets with protective surfaces to shield them from direct contact with sunlight. Maybe that's noting a harmful effect because you need a protective surface. Plants on Earth need direct contact with sunlight to produce energy and nutrients. We learned about that in photosynthesis. Too much time in the sun's UVB rays can cause sunburns or worse, skin cancer. And then UVB rays from sun can damage your eyes after prolonged exposure. That seems like a risk as well. All right, so is there a connection between the amount of sunlight and the production of vitamin D? Let's look at this graph. Here we have an increase in the exposure of sunlight in hours from 12 to 24. And then this is the serum vitamin D, so that's how much vitamin D is in your blood serum. Based on the graph, yes, there seems to be a direct relationship between the hours of exposure and the amount of sunlight in one's body. And so the difference here between a direct and inverse is that in a direct relationship, there's an increase in one, there's an increase in the other. An inverse is while one increases, the other decreases. Oh wow, and be very careful here. Sunlight, not sunlight, but vitamin D. There we go. All right, so here we're looking at some evidence. Here's a percentage of adults with a vitamin D deficiency in the UK. So here we can see in winter, pretty high, and in summer, it's a little bit lower. Seems to be more so in the northern latitudes than in the southern latitudes. seems to be true. Based on the evidence shown, what might explain the levels of vitamin D deficiency in the UK during the winter months? Lack of food, lack of rain, lack of adequate sunlight, the drop in average body temperature, or change in their sleep cycle. Well, the main thing that's going to change between winter and summer, my guess, in the UK is going to be the sunlight. Maybe rain or body temperature would be involved, but it seems most likely that that is what that's all about. So could this be a reason why there's less bone density for our astronauts? Vitamin D, let's learn a little bit more. It is a vitamin your body naturally produces when your skin cells are exposed to the ultraviolet rays of the sun. But you may be wondering, what does this have to do with protecting my crew's bones? Well, vitamin D can actually help with that. Take a look at the study that uncovers one of vitamin D's key roles. Here's the study. It says the effects of vitamin D on calcium absorption. Here's study A. Patients received vitamin D beforehand, and study B is without vitamin D. So you can see there's a 64% increase in the amount of calcium absorption. Which of the following statements match the data from the lab? Vitamin D's increases one's blood pressure. Groups who have adequate amount of vitamin D absorb 65% more calcium from their diets. Vitamin D increases the amount of sunlight the body receives. Vitamin D can increase the amount of calcium absorbed in the body, or vitamin D has no noticeable role. Okay, and the two best answers here are the ones that link vitamin D with calcium. Alright, so let's make a connection here. Can the sunlight affect the health of your crew's bones? Let's see if that affects bone health. Okay, so astronauts get enough sunlight while aboard their spacecraft, or is it since astronauts cannot expose themselves to direct sunlight, they do not receive enough sunlight? Seems right. Vitamin D. Direct contact with sunlight allows astronauts to produce enough vitamin D for their bodies. Direct contact with sunlight allows astronauts to produce a lot of calcium. The lack of sunlight the astronaut received causes them to be dizzy. Okay, well, what we've been talking about here is the last one. The lack of sunlight the astronauts receive can cause vitamin D deficiency in astronauts. And then how does that affect calcium? If we have a vitamin D deficiency, that can prevent enough calcium from being absorbed. Okay, well, I don't know if you guys are also going to come into this issue, but this is obviously the best answer. And they say so, but then they say that you're wrong. So, I don't know. I guess just kind of move through that. Oh, here, wait. That is definitely the right answer. That was 1, 2, 3. Didn't see this one down here. Alright, a decrease in calcium absorption prevents the body from building and maintaining bones. That seems about accurate. Alright, cool. Never mind. Here we go. Calcium in your bones. Reduced calcium absorption can put your crew's bones at risk. Okay, so when there isn't enough calcium, the body has to respond. So, lack of sunlight, decreased vitamin D, lower calcium absorption, not enough calcium to maintain the bones. How do you predict the body will respond to a vitamin D deficiency and a reduction in calcium absorbed from one's diet? So we're at this stage right here. How do you think the body's going to try to maintain homeostasis? Probably try to raise the calcium levels. And not above, but just to restore. How does this happen exactly? When vitamin D levels are low, your body does not absorb the calcium it needs. Take a closer look at the crewmates who do not have enough calcium in their bodies. Let's see what's going on. You can click on these question marks. Here's a gland called the thyroid in your throat, senses low levels of calcium in the blood. Start taking notes on this. This seems pretty interesting. In response to these low levels of calcium, the gland releases a hormone called PTH, or parathyroid hormone. Parathyroid hormone triggers bone-dissolving cells to become active. And then do you remember what those bone-dissolving cells are called? Those osteoclasts. Very good. When bone is dissolved, the mineral calcium stored in the bone enters the bloodstream. Yeah, and we learned about how the bones are actually mineral deposits, and here's how. I like that the blood vessel looks like a PVC pipe. That's funny. Anyway, dissolving bone in this manner increases the level of calcium in the blood back to normal levels, or stable, stasis, right? Homeostasis. When the level of calcium returns to the normal, a signal is sent back to the gland to stop producing PTH. So this is what we call a negative feedback loop. So something happens, it increases one thing, that thing then goes back and turns off the switch. It's like, I need water, turn water on. I have enough water, turn faucet off. And that's just happening with the calcium. Okay, so go ahead and take some notes on that. And I'll show you my notes as well. I'll pause this in order to record the notes. Okay, so in a lot of words, I put it into a real quick diagram here. Here we're in the under your skin. Okay, so from the beginning, increased sunlight, increased vitamin D, that's a direct relationship. Increased vitamin D equals increased calcium absorption. What happens if you have decreased calcium? Thyroid detects, releases parathyroid hormone, bone dissolving cells become active, calcium is released from that solution, and that goes back and tells the thyroid to turn off. Okay, let's keep learning. There's some more vocabulary to add in here. All right, so the vocabulary mainly we need to add in is something called homeostasis. And let's see, I do want another color. I got green, take notes with. So I'm going to write that into my notes. Homeostasis. Definitely a vocabulary term I might ask you on your DBA. Really important for the body to maintain itself. And you might write a definition here, process by which an organism regulates itself to maintain internal conditions. So regulates to maintain internal conditions. Okay, like we just saw with this example. I don't think we have, do we have to do something? Okay, so let's place the steps in order. To reiterate, we have the thyroid sensing low levels of calcium. When the levels of calcium return to normal, it sends, so that's the last thing that happens. Dissolving bone in this manner, okay, this hormone. In response to these low levels of calcium, the thyroid releases a hormone. This hormone, called PTH, parathyroid hormone, triggers bone dissolving cells. Dissolving bone in this manner increases the level of calcium. When the bone is dissolved, this actually releases calcium into the bloodstream. I guess it's probably like this. Okay, and that would be that. Cool. Complex machinery we got here. And like I said, that's a negative feedback. So I'm also going to write this down. Negative. And that's when one thing gets going, it shuts it off when it's reached the stable state again. Negative feedback is a response that opposes a change that disrupts a set parameter in the body. For example, if the temperature rises beyond a set point, your body will counter that by doing the opposite, cooling you down. Negative feedback loops are common. Examples include controlling the amount of sugar in your blood or regulating blood pressure. That's a pretty interesting example considering what we're learning about with sugar. What is that hormone, just like what did we just learn? PTH. What's the hormone that regulates blood sugar levels? And that would be insulin. Okay, so we've learned about how if there's too much glucose in your blood, the insulin is going to be triggered saying, take up glucose. If there's not enough glucose in the blood, the insulin stops taking up glucose and instead releases glycogen. Which of the following is an example of a negative feedback loop? Select all that apply. A house's thermostat senses the temperature is too warm and turns on the air conditioning. And that would be true because something's getting too warm, going above, and then trying to bring it back down to normal conditions. All right, I guess outside the body, but in real life, maybe you've given away too many free ketchup packets and your boss yells at you to stop doing so. Yeah, you go out of bounds and then you have to come back in bounds. That's a strange example, but anyway, when you get cut, platelets in your blood go to the site and signal more platelets to stop the bleeding. So here, this is signaling more of something, not less. So that would not be negative feedback, that would be positive feedback. Once your temperature gets too low, your body begins to shiver. Yep, so too low and then tries to bring it back up. And then oxytocin is a hormone that causes contractions in childbirth. Once a little oxytocin is released, it triggers more oxytocin to be released. And this again is positive feedback. One thing says more, more, more. All right, in summary, let's see here. Complete this diagram. Lack of sunlight. We have a reduced vitamin D production. That reduces calcium absorption. That probably increases the production of PTH, and that leads to the loss of the bone. And I'll go ahead and write that down in your notes too. Okay, and if you're into making your notes fun and colorful with me this morning, I redid it here. Drew a couple little pictures, drew in the thyroid, looks like a butterfly, drew a bone. I mean, you could get super bonus points and draw in what vitamin D looks like, but anywho, next slide. The down low on vitamin D. Using vitamin D to prevent bone loss. Based on what you've seen from your research, why is vitamin D so important? Certain vitamins, such as vitamin D, help the body, what do we got here? Absorb calcium from your diet. Vitamin D is a chemical that can be produced by your body using sunlight. Astronauts in long-term spaceflight who do not have contact with the sun have to make sure they get enough vitamin D in their diet because they don't have sunlight. Okay, so where do we get them in our diet? We can get them from supplements. You guys ever take these pills? They're bright and fun and look cool, but they're filled with vitamin D. Or in your diet, such as cheese, fatty fish like tuna and mackerel, and egg yolks. This is roe. Those are eggs, salmon eggs. Edamame, I think that is right there. Probably has good. I'm really obsessed with edamame right now. Actually, I'm going to put that on my grocery list. So maybe you put some of these foods on your grocery list. Ask your parents. Which of the 3 following things do you think would be the most helpful for astronauts to maintain a high level of vitamin D? Looks like fish, cheese, pills, probably not cookies or strawberries, and celery, and another thing going on my grocery list, because celery and peanut butter, I think is the best snack, healthy snack ever created. All right, but it might be interesting, and I think about this in my own life, like, are you getting enough vitamin D? So what is enough vitamin D? Let's get into the details here. Based on what you've learned about vitamin D, you may want to make sure your crew gets enough. Okay, vitamin D is measured in international units, or IUs. 1 IU of vitamin, is, okay, 0.00000025 grams. And you can put that in scientific notation. Anyone know how? Move that decimal point. 1, 2, 3, 4, 5, 6, 7, 8. So 2.5 times 10 to the 8th. That is about 1 million times smaller than the weight of a grain of rice. Crazy. Assuming your crew is between the ages of 19 and 70. Here we go. So we're in these 2 ranges. What is the daily intake that they should receive? Looks like about 600 IUs. So that would be that number there, 2.5 times 10 to the negative 8th times 600. And I am curious, how do they get those numbers? Something to research after this lesson. Astronauts receiving 10% of their daily recommended value of vitamin D are getting enough of the vitamin. If your crew was to eat the meal plan below, would they receive sufficient vitamin D? So let's take a look. We got 10% here. Okay, so we're looking for something that says 100%. If we add these all up, 10%, 20%, now we're at 30%, 30%, now we're at 60%. Are we getting enough? Nope, we're not at 100%. And I'm going to go ahead and write down that the recommended value is 600 IUs. All right, so let's take control, vitamin D. As a commander, what would you change? What would you institute to provide your crew with enough vitamin D to maintain their bones? Add 60 grams of sugar. That's a bizarre option. Let's not choose it. Add fortified oatmeal. Ooh, 320 IUs. That's amazing. I was just about to go make some oatmeal. Potentially oat milk. I wonder if oat milk would have, I guess you can make that pretty easy too, just oats and water in a blender. So that would be cool. Would that get us there? Let's consider what we're at. We're at 60%. 60% of 600. I'll calculate that out. And you can use a calculator here, but 0.6 times 600, that's how you do that. And we are at, oops, here we are. Okay, so we need 360. Ooh. All right, so then maybe we add a supplement. It's probably the easiest way to get there. Although I like the oatmeal option. And we could add more fruits. That's probably a good thing, but add a supplement. All right, cool. I think that's the best option. Oh gosh, but I didn't read that very well. So here we go. That's going to be a good option. We're close to. That said calcium. I thought that said vitamin D. Here we are. There we go. Cool. So oatmeal for the win. That's awesome. Are you getting enough vitamin D in your diet? Just like astronauts need this, we need this as well. Use the internet to look up 3 foods you ate yesterday. Add up the percentage vitamin D in each. Approximately what percentage of your daily intake you consumed yesterday? Oh, this is fun, especially if you guys are taking the challenge with me and trying to record your food. Okay, so let's see. Foods, I'm just going to do my own and you can sit there and do yours, but I ate a sweet potato. I wonder. I mean, I don't think I ate the whole sweet potato. I ate with a friend, so I probably ate half of a sweet potato. Let's see how much vitamin D does a sweet potato have. 0! So sad. Okay, well that's a little depressing. All right, what about I ate a curry, so I also had rice. 0. Oh my gosh, I'm striking out. What else did I eat yesterday? I ate a pear. Lots of folate, which is an important vitamin for childbearing, interestingly enough. Vitamin C, but let's see, where's vitamin D? Is this going to be here? Doesn't quite say, which makes me think that it doesn't have a lot of vitamin D. Let's see, I guess I also put an egg. I put an egg on my curry because I really like topping things off with a fried egg. Egg, vitamin D. 44! Woohoo! Okay, so I have a little bit. You know, I spent the whole day out in the sun though, so I think that was probably a good ticket. But maybe I should consider adding in, I guess like today, having some fortified oatmeal. Well, how much does regular oats have? Because then I put like collagen in it. Though fortified cereals and oatmeals provide less vitamin D than many natural sources, they can still be a good way to boost your intake. Foods such as cow's milk, soy milk, orange juice, cereals, and oatmeal are sometimes fortified with vitamin D. Yeah, I suppose you could get vitamin D fortified milk. Let's just look here. Top 15 best foods. Let's see. Okay, this is like a goofy. We have to look at the gallery to figure that this. I hate these websites. Cheese, tofu, almond milk, soy milk. Mushrooms. Yes, I had some mushrooms. That's cool. Oatmeal. Yeah, but Quaker Oats, you guys, also look at if you eat Quaker Oats, how much sugar is there? It might not be worth the trade-off. So it seems like, looks like you have to get fortified oatmeal with vitamin D. Cereals oftentimes are fortified. Salmon, cool, I love salmon. That's a good thing. Milk, almond and soy. I wonder if cashew or oat milk is the same. Eggs, okay, about 40. Tuna, 154. Yogurt, only if it's fortified. Sardines, oh, I love sardines, these little packs. Vitamin D. Orange juice, oh, sardines, especially when you're backpacking, are good. Swordfish, ooh, yum. Okay, cool. Well, that was informative. Go ahead and do that for yourself. Add up how much vitamin D you had total. And finally here, using vitamin D in your diet, text a family member what you learned about the importance of vitamin D for space travel. I love this. I love that your mom or dad or aunt, uncle, or sister, you know, it's my sister's birthday. Maybe I'll also just send her a text about the importance of vitamin D. Make sure to mention the importance of sunlight, vitamin D, calcium, and bone in your message. All right, well, I'll do that right now. And then I'm going to go eat some oatmeal that may or may not be fortified. I'm going to go check the label. But I'm going to add in, I don't have, maybe macadamia milk. I'm going to see, that's what I have right now. My macadamia milk has vitamin D. Cool thing, keep track of your diet stuff here, and then you can do the My Body, My Experiment for your experiment, which is due at the end of the course, as an experiment, as your semester 2 experiment. All right, I hope this has been helpful. Have fun with this lesson, and we'll talk more about things to research right now, or how do they get those recommended daily values. I wonder if it's by figuring out how, like, someone or something, maybe a rat, because oftentimes we do these things in rats first. Like someone who is vitamin D deficient, we figure out like, oh, it seems like your bones are losing mass in this amount. It seems like you didn't get this much vitamin D. Let's increase the vitamin D recommended daily value in IU's international units. All right, cool. These are my notes. I'll link them. Just take a picture and put them up for you. Cool. See you on the next lesson.